Hello. In this video we are going to see how to find the domain of definition of some logarithmic functions. In the first function we have f of x equal 2 ln x minus 2 plus 3. In order to find the domain for this function, I need first to set the condition for this function to be defined. So as you can see here, I just have this x minus 2 inside ln. So the condition here will be x minus 2 should be strictly positive. So this implies x should be strictly greater than 2. So my domain for f will be d of f, which is I need all values greater strictly than 2. It means open at 2 till plus infinity. So this is the domain for the first function. Now for the second function, if I go to the second function, in the second function we have g of x equal minus ln x squared minus 2x plus 3. So again, what we have inside ln here is x squared minus 2x. So the condition will be x squared minus 2x should be strictly greater than 0. So we have to solve first x squared minus 2x equals 0. And in this case, I may factorize it using or taking x common factor. So it's x into x minus 2 equals 0. So we get x is 0 or x minus 2 equal to 0. So x is equal to 2. So these are the roots for this quadratic. Once I found the roots, we set them on the real number line. So 0 first, then 2. And I start to choose values. I try values in order to know this quadratic when it is positive and when it is negative. If I choose a value 1 here and substitute it in this quadratic, so we get 1 squared minus 2 times 1, which is 1 minus 2, which is minus 1, hence it's negative. So between 0 and 2 my sign is negative. If I try 3 here, we get 3 squared, so we get 3 squared minus 2 times 3, which is 9 minus 6, which is 3, which is positive. So here it's positive. Also, if I try less than 0, which is minus 1, also we are going to get positive. So we are looking when this quadratic is positive. So obviously this side it's positive and this side it's positive. It means whenever x is strictly less than 0 or x is strictly greater than 2. It means my domain of g is everything less than 0 till minus infinity. So it's open interval minus infinity till 0, open, union, because it's going to be union, from 2 till plus infinity. So open at 2 till plus infinity. So this is the domain for the function g. So if I choose any value for x in this interval or in this interval and I substitute it in the function g will be defined. Okay, my function g will be defined. For the third function, if we go to the third function h of x, which is ln 2 minus x squared, and we have another function which is k of x, which is 2 ln 2 minus x. So we have here two functions, h and k. Let us find first the domain for h of x. So in order to find the domain for h of x, we are going to set the condition first. What's inside ln I need it to be strictly positive. It means here 2 minus x, all of it square, I need it to be strictly positive. Now when this is strictly positive, in fact anything square is always positive, right? So anything power 2 will be positive, but we should take care of something here is that I don't even need it equal 0, I need it strictly greater than 0. So when this term is equal to 0, 2 minus x squared is equal to 0 if and only if 2 minus x is equal to 0, which is equivalent to say x is 2, right? So for this value 2 minus x squared is going to be equal to 0, and I don't want it to be equal 0, I need it to be strictly positive. So I should take any value for x except, so x can take any value, x can take any value except 2, x equal 2. So x can be anything except 2, because if I substitute here instead of x any value, if I think of any value, positive, negative, anything, when I make squaring, it's going to be positive, right? So the only problem here is that when 2 minus x is equal to 0, it means when x is equal to 2. So my domain will be everything except 2. So if I look here on the number line, I may choose all the values here or here, but I need to jump above 2. So the domain for h is going to be equal, so from minus infinity open, from minus infinity till 2 open, union from 2 till plus infinity. Okay, in this case I will be taking all these values and all these values, excluding the 2. So this is the domain for h. Now the second function is k of x, which is equal to 2 len 2 minus x. So this function here, to be defined, I need what's inside len should be strictly positive. It means 2 minus x should be strictly positive. So this is for the second function, k of x. So k of x to be defined, 2 minus x should be strictly greater than 0. It means minus x strictly greater than minus 2. Multiplying by minus both sides, we are going to get x is strictly less than 2. Okay, so it means I may take all values less than 2. So this is 2, I need all these values less than 2. It means the domain for k is from minus infinity open, from minus infinity till 2 also open. So this is the domain for k. So as we can see here, the first function h, the domain for the first function h is all these, so everything except 2, while the domain for the second function k is minus infinity, just minus infinity 2. If we go back to our functions, you can see that the two expressions are the same, in fact, because we have a property that says len a power r is equal to r len a, right? So len 2 minus x squared is equal to 2 times len 2 minus x, applying this property. But we should take care of something here, is that the domain for this function is different from the domain of this function. Okay, so as expressions, the two expressions are the same, but if we look for the domain for this function, we get the domain will be everything except 2, while the domain for the second function will be x is less than 2. Okay, so we should take care for the domain of each function. Now let's go to the fourth function. In the fourth function we have j of x equal x over x minus 1 times len x. So in this function, this is composed of product of two functions. The first function is irrational times the len. So we have here in fact two conditions for this function to be defined. The first condition is on the len, or what's inside len. Here, for this len to be defined, I need x to be strictly positive. This is the first condition. And the second condition is on the rational. For this rational to be defined, I need the denominator to be not equal to 0. So the second condition is x minus 1 shouldn't be 0. So x minus 1 shouldn't be 0 gives x can't be 1. Okay, so let me correct this handwriting. So the second condition is x minus 1 can't be 0. So this means x can't be 1. So these are the two conditions. First, x strictly greater than 0, and the second, x can't be 1. So if I look for on this number line, this is 0 and this is 1. So I can take all values of x greater than 0, except I don't need this one here. So it means my domain should be, I can take all values, okay, all values from 0 till 1. So I don't want to take 0 because strictly greater than 0. So it's open at 0 till 1, also open at 1 because I don't need 1. Then from 1 till plus infinity, union from 1 till plus infinity. So this is the domain for J. Let's go for our last function, which is u of x, which is radical len x plus 1 over 2 minus x. For this function to be defined, which is composed of the radical and the logarithm inside the radical. So we have two conditions for this function to be defined. The first condition should be for our len to be defined. So in order for this len to be defined, I need what's inside len to be strictly positive. So our first condition is that x plus 1 over 2 minus x, I need it to be strictly positive. This is my first condition. So let us solve this condition first, and then we go to the next condition. So when this condition is satisfied, so this is equivalent to say x plus 1 times 2 minus x is greater than 0. So in order to solve this greater than 0, first we solve it. X plus 1 times 2 minus x is equal to 0. So it means x plus 1 first equal to 0, or 2 minus x is equal to 0. So first one, x equal minus 1, this is first root, and second x equal 2, this is second root. So put them on the number line, minus 1 and then 2. If I choose 0 in between and substitute it here or here, it doesn't matter, we are going to get, so what we are going to get is 0 plus 1 over 2 minus 0, which is equal to 1 over 2, okay, which is positive. It means in between here we have positive, and here we have negative, negative. So we are looking for, I need the sign to be positive. It means this condition is satisfied, x plus 1. So x plus 1 over 2 minus x is positive if and only if our x should be between minus 1 and 2. So this is the first condition is satisfied for this solution. Now what is the second condition? Because we have this logarithmic function is under the radical, so for this function to be defined, I need what's inside the radical to be greater than or equal to 0. It means our second condition here is that I need len of x plus 1 over 2 minus x. I need it to be strict or greater than or equal to 0 because it is under the radical. So how to solve this greater than or equal to 0? I need to recall a property here about logarithmic function. The property says that len u is positive if and only if our u is greater than 1. Okay, so this is a property. So applying this property here, it means what do we get here? So this is our u here. This is u. So len u is greater than 0 if and only if u is greater than 1. It means u plus 1 over 2 minus x. I need it to be greater than 1. So how to solve this? This is equivalent to say x plus 1 over 2 minus x minus 1. I need it to be positive, so I common denominator. The common denominator here is 2 minus x, so we get x plus 1 minus into 2 minus x, so I need this to be positive, equivalent to say we have so x plus 1 minus 2 plus x over 2 minus x. I need it to be strictly positive. So what do we get here? If I simplify, we are going to have 2x minus 1 over 2 minus x, over 2 minus x. I need it to be strictly positive. So in order to solve this strictly positive, it is to solve 2x minus 1 multiplied by 2 minus x. I need it to be positive. In order to solve this positive, we solve. So first I have to solve 2x minus 1. So we have to solve 2x minus 1 times 2 minus x. I solve it equal 0 first. It means 2x minus 1 equals 0, or 2 minus x is equal to 0. So we get 2x is equal to 1. It means x equal 1 over 2, or x equal 2. So we put them on the number line. So the number line is formed of half and 2. If I try 0 here below half, if I try 0 in my expression, this expression I mean, okay, in this expression, so if I substitute 0, we are going to have 0 minus 1 over 2 minus 0, so 0 minus 1 over 2 minus 0, which is minus half, which is negative. So here we know it's going to be negative, here it's going to be positive, and here it's going to be negative. Now what we are looking for is, I need the sign to be positive, right? I need the sign to be positive. So when we have it positive, it's positive. So let's write 2x minus 1 over 2 minus x is positive if and only if x is between half and 2. So this is the solution for the second condition. So I have two conditions should be satisfied for my function to be defined. The first condition is x between minus 1 and 2. This is my first condition. The second condition, so between minus 1 and 2, and between half and 2. So we should set a number line again. and set the values from the smallest to the greatest. The first value is -1, then half, then 2. So the first condition, x should be between -1 and 2, so this is the first condition. The second condition, I need x to be between half and 2, so here half and 2. Okay, so we can take 2 in the first condition, or no, 2 is not included in the first condition, while in the second condition, so we have here or equal. Here we may have or equal. Okay, so here we have or equal, and here we have or equal, and here we have or equal. Okay, because we needed len to be greater than or equal to 0. So let's continue this. So here we should have or equal, so here we have or equal. So the solution, the second condition, we should have or equal. Okay, or equal here, so it means or equal here, or equal here. Now, so the first condition, there is no or equal. In the second condition, we have or equal. So we can take 2 in the second condition, but we can't take 2 in the first condition. So I need both conditions to be satisfied at the same time. It means I need the common area between the two solutions. Hence, our solution should be x between half and 2. In the first condition, 2 is not included, while in the second condition, 2 is included. So the common, it won't be included. But for half, we have or equal at half. So this is the final solution. It means the domain for our function u, okay, it's going to be closed at half, closed at half, closed at half, to open at 2. So this is the domain for our last function. Thank you, and see you in the next digits.